Deep under the sunlit streets of Pozzuoli in southern Italy, the ground beneath 500,000 people is silently pushing upward at this very moment. Heavy stone walls and ancient Roman ruins crack open as superheated gas and steam force their way through solid rock beneath the bay. Deep underground, a sleeping giant is shifting in its bed, pumping hot fluids into hidden chambers just 2 miles beneath the surface. Thousands of tiny quakes shake the coastal homes every year, but nobody standing on the beach can see the true danger growing below. If you love exploring real science mysteries and want to stay ahead of the biggest geological discoveries before everyone else talks about them, make sure to hit that subscribe button right now. We dig past the dramatic headlines to bring you the genuine truth about how our changing world works. Join our growing community of curious minds so you never miss an unbelievable story from deep inside our planet. To understand why scientists all over the globe are watching this exact spot in Italy with such intense focus, we first have to take a quick step back in time. Most people around the world have heard of Mount Vesuvius, the famous volcano that buried the ancient Roman city of Pompeii under ash nearly 2,000 years ago. Mount Vesuvius is what most of us picture when we hear the word volcano, standing tall as a steep mountain peak against the sky. But just a few miles west of Naples lies a completely different kind of monster, hidden right in plain sight. This hidden region is known as Campi Flegrei, an ancient Greek name that translates directly to the burning fields. Instead of a towering mountain peak rising up into the clouds, Campi Flegrei is what geologists call a caldera. A caldera is basically a massive, bowl-shaped crater that forms when a huge volcano erupts so violently that its roof collapses into the empty space left behind underneath. The bowl at Campi Flegrei is over 8 miles wide, stretching across land, bustling towns, and even out into the blue waters of the Mediterranean Sea. What makes this place so fascinating, and frankly terrifying, is that people have built their entire lives right inside this sunken crater. Today, more than 500,000 people live directly inside the boundaries of the ancient volcanic bowl, while another million live just outside its edge in the greater city of Naples. They drive on streets paved over ancient lava flows, grow grapes on rich volcanic soil, and build homes on land that slowly moves up and down over the centuries. It is one of the most densely populated volcanic danger zones anywhere on Earth. For a very long time, scientists knew that this region had a wild and explosive history. Nearly 39,000 years ago, Campi Flegrei suffered a mega eruption that was so gigantic it altered the climate of the entire planet. That single explosion blasted over 30 cubic miles of ash and melted rock into the atmosphere, creating a cloud so thick it blocked out sunlight across Europe for years. Some researchers even believe that global cooling from this colossal blast played a major role in the extinction of the Neanderthals. Another huge explosion occurred about 15,000 years ago, covering the region in a layer of yellow rock known as yellow tuff. After that, the volcano settled down for thousands of years, giving early humans a chance to build thriving communities along the sunny coast. But the volcano was far from dead, and it proved that fact in a very dramatic way almost 500 years ago. In the year 1538, after more than a century of strange earthquakes and ground swelling, the ground opened up near the town of Pozzuoli. In just 8 short days, the volcano erupted and built an entirely new mountain, which locals named Monte Nuovo, or New Mountain. That eruption blew away part of the countryside and ruined several small villages, but then the volcano went quiet once again. For nearly 450 years, the burning field seemed peaceful on the surface, offering little more than bubbling mud pools and smelly sulfur vents for tourists to marvel at. But deep beneath the surface, the heat and pressure were slowly building back up. Did you know that an entire ancient city was built right inside a volcano crater that is still moving up and down today? Leave a comment below with your thoughts on what it would feel like to live on top of a giant sleeping volcano, and drop a quick like on this video if you find natural history as mind-blowing as we do. It helps us share these wild, true stories with more science lovers like you. Now, to really grasp the mystery of what is taking place right now, we have to look at a strange geological phenomenon called bradyseism. Bradyseism comes from ancient Greek words meaning slow movement of the earth, and it describes how the ground in Campi Flegrei gently rises and falls over long periods. You can actually see physical proof of this vertical movement on the stone pillars of an ancient Roman marketplace built 2,000 years ago in Pozzuoli. Dark bands of tiny holes drilled by ocean clams are visible high up on those marble pillars. Those shellfish marks prove that the market once sank completely under the sea, stayed underwater long enough for sea creatures to live on the stone, and was then pushed back up into the dry air by forces deep underground. For decades, scientists believed that this slow breathing of the ground was caused purely by rainwater heating up and trapped steam creating mild pressure changes. They expected that the ground would gently rise for a few months or years, lose steam, and then sink back down to its normal resting level as it had done for centuries. Here is the exact point where that old idea started to completely fall apart. Between 1969 and 1972, the ground beneath Pozzuoli began to lift rapidly, raising the town by several feet and causing widespread panic among residents. Scientists carefully watched the area, hoping it was just a temporary spike that would quickly calm down. While the ground did stop rising after 1972, the respite was brief. Just 10 years later, an even more alarming phase of ground movement began that changed everything researchers thought they knew about the area. Between 1982 and 1984, the ground beneath Pozzuoli did not just gently wiggle, it surged upward by nearly 6 feet in less than 2 years, triggering thousands of scary earthquakes that cracked walls and forced 40,000 residents to evacuate their homes. Harbor docks became completely useless as the sea level appeared to drop, though in reality, it was the land itself lifting out of the water. After that intense crisis passed, the land slowly sank back down by a small amount, and experts assumed the system would return to a long period of quiet rest. Starting in the year 2005, instrument networks monitored by the Vesuvius Observatory noticed that the ground was rising once again, slowly at first, but with steady persistence. Over the last 20 years, that gentle inflation has accelerated into a major geological event. Measurements taken by ground sensors and satellite radar show that the soil near the center of the crater has risen by over 5 feet since 2005. The land is not just moving, it is stretching and straining like a balloon pushed to its breaking point. When scientists first saw this modern surge, many believed it was just another brief cycle of trapped geothermal water, similar to what happens in natural hot springs. They expected the swelling to slow down on its own without causing major structural damage to the cities above. But what was actually found by advanced monitoring tools shattered those mild expectations entirely. The rate of ground uplift did not slow down, it actually sped up. In recent years, the land has been rising at speeds exceeding 1 inch every single month during peak periods. Alongside this dramatic ground inflation came an explosion of earthquake activity that shocked local residents. During the 1990s and early 2000s, quakes in the region were rare and very weak. But since 2018, thousands of small tremors have rattled the bay every year, with the earthquakes growing progressively stronger and shallower. In 2023 and 2024, multiple magnitude 4.0 and 4.4 quakes struck right near the town of Pozzuoli, shaking buildings, knocking plaster from ceilings, and waking families in the middle of the night. Why does this gap between what experts expected and what is actually happening matter so much? Because when solid rock under a city stretches upward by 5 feet and gets hit by thousands of quakes, it loses its structural strength. Recent studies conducted by University College London and Italy's National Institute of Geophysics and Volcanology revealed that the thick crust above the volcano is no longer behaving like elastic rubber. Instead, it has become brittle and fractured, making it far easier for fluids and gas beneath to force their way toward the surface. What do you think is causing the ground under Italy to rise so fast right now? Have you ever felt a strong earthquake in your hometown or seen a real volcano up close? Tell us your stories in the comments below, and subscribe to the channel if you want to keep exploring how scientists solve these high-stakes planetary puzzles. Here's the key detail that completely changed how scientists view this entire event. For years, geologists debated whether the ground was being pushed up by liquid magma, superheated water, or trapped steam. Many researchers argued that magma was safely locked away miles deep in the earth and was not actively moving upward. They believed that the swarms of quakes were caused purely by deep, hot water boiling in underground hydrothermal reservoirs. But brand new high-resolution seismic studies published recently tell a much more complex story. By using thousands of earthquake waves like a giant medical ultrasound machine, geophysics teams were able to create precise three-dimensional maps of the rock structure miles beneath the crater. What they discovered deep underground was not just a simple pocket of hot water. The imaging revealed 2 distinct pressurized sources stacked on top of each other like levels in a subterranean building. The deeper source lies between 4 and 5 miles down, right beneath the bay of Pozzuoli. This deep chamber is filled with what scientists call magmatic fluids. When magma stays under immense pressure deep inside the earth, it releases superheated gases like carbon dioxide, sulfur dioxide, and water vapor dissolved in the molten rock. These magmatic fluids are far hotter and under vastly higher pressure than ordinary hydrothermal water. The research shows that this deep reservoir has been actively leaking superheated gas and fluid upward, injecting extreme heat and pressure into the shallower rocks directly above it. What researchers uncovered next shocked everyone who was studying the area. As those deep magmatic fluids force their way upward through cracks in the rock, they encounter a secondary chamber located just 1 to 2 miles beneath the surface near the Solfatara crater. This shallow zone acts like a giant pressure cooker. The superheated gases from the deep magma pool are rushing into this shallower reservoir, mixing with groundwater and expanding with incredible force. This double-pressurized system is the exact engine driving the accelerated ground uplift and the relentless earthquake swarms. To make matters even more intense, scientists monitoring the surface emissions at Solfatara and nearby Pisciarelli have recorded drastic changes in the gas coming out of fumaroles. Fumaroles are natural vents in the ground that release hot volcanic gases and steam into the air. For decades, these vents released mostly water steam mixed with mild sulfur compounds. But chemical analysis of the escaping gas shows a massive jump in the concentration of carbon dioxide coming directly from deep magmatic origin. Originally, scientists expected that the gas composition at the surface would remain relatively stable unless a full-scale eruption was immediately about to happen. What was actually found, however, is that the ratio of magmatic carbon dioxide to water vapor has been rising steadily for years. The gas vents are now spewing hundreds of tons of carbon dioxide every single day, and the temperature inside the main Pisciarelli vent has climbed past 390 degrees Fahrenheit. Why does this chemical change matter so much to the people living above? Because it proves that the barrier between the deep magma body and the surface is becoming much more permeable. The rock cap that spent thousands of years holding back these extreme pressures is cracking and leaking. The rising magmatic fluids are not just pushing the ground up, they are actively baking and altering the rock layers, turning hard, strong stone into weak, crumbly clay. When solid rock underground gets baked by 400-degree steam over long periods, it undergoes a process known as hydrothermal alteration. The hard mineral crystals that make up the rock dissolve and transform into soft clay minerals. This means the solid ceiling holding back the volcanic pressure cooker is getting thinner, weaker, and softer with every passing month. Instead of acting like a heavy stone lid, the earth beneath the bay is becoming fragile and riddled with microscopic cracks. As these underground cracks open up, the magmatic fluids find easier pathways to rise closer to the surface. This creates a dangerous feedback loop where rising pressure cracks the rock, which allows more gas to enter, which weakens the rock even further. Scientists tracking these changes say this structural weakening explains why even small pressure increases underground are now triggering larger and more frequent earthquakes across the entire region. How would you feel if you learned that the ground beneath your home was slowly turning into soft clay from underground heat? Leave a comment down below with your thoughts, and smash that like button if you want us to bring you more in-depth coverage of Earth's biggest hidden forces. To fully understand the scale of what is happening at Campi Flegrei, it helps to compare it to other famous supervolcanoes around the world. Most people have heard of Yellowstone in the United States, which is often called the world's most dangerous supervolcano. Yellowstone sits on top of a massive plume of hot rock that has generated incredible eruptions over millions of years. But while Yellowstone gets the most movie screen time and news headlines, Campi Flegrei poses a far more immediate risk to human life due to one simple factor: population density. Yellowstone National Park is surrounded mostly by wilderness, forests, and wide open plains, with relatively few people living directly inside its ancient caldera walls. If Yellowstone were to experience a localized steam explosion or minor ground movement, very few homes or buildings would be directly in harm's way. Campi Flegrei, on the other hand, is completely surrounded by towns, cities, schools, hospitals, and historical landmarks. 500,000 people live right inside the crater, making any movement of the ground an immediate threat to everyday human safety. Another comparison can be made to the Taupo supervolcano in New Zealand or Long Valley caldera in California. Both of those systems experience regular earthquake swarms and occasional ground swelling as deep fluids shift underground. However, Campi Flegrei stands out because its rate of ground rise over the past 20 years is among the fastest and most sustained ever recorded at any caldera on Earth in modern history. The sheer speed of the land movement is what keeps geologists on high alert day and night. Scientists use advanced satellite tech to keep an eye on every square inch of this active zone. A technique called interferometric synthetic aperture radar, or INSAR for short, allows satellites orbiting hundreds of miles above Earth to bounce radar signals off the ground. By comparing radar scans taken weeks or months apart, researchers can measure ground movement down to the fraction of an inch. These satellite maps reveal a distinct bullseye pattern centered right near Pozzuoli, showing that the ground is lifting most dramatically in the middle of the caldera. In addition to satellite radar, ground teams have placed hundreds of permanent GPS stations across the region. These stations are anchored deep into solid rock and transmit location data continuously. Whenever the ground shifts even a tiny millimeter, the GPS network registers the movement instantly. This constant stream of data feeds into supercomputers at the Vesuvius Observatory, giving researchers a real-time view of how the volcanic bowl is expanding and twisting under pressure. Despite all this cutting-edge technology, interpreting the data is still a massive puzzle. Scientists must constantly ask themselves whether the rising ground and earthquake swarms mean an eruption is getting closer, or if the system is simply venting off excess steam and gas safely. Volcanoes are notorious for showing signs of intense activity for years or even decades before returning to a quiet state without ever erupting. This uncertainty creates a difficult challenge for civil protection officials who are responsible for public safety. If authorities issue an evacuation order too early, hundreds of thousands of people will be forced to leave their homes, businesses, and schools, causing massive economic and social disruption. But if authorities wait too long to act, a sudden eruption or severe earthquake could put countless lives in immediate danger. Striking the right balance requires an extraordinary level of scientific accuracy and careful planning. What do you think is the hardest part of managing a natural hazard like a sleeping supervolcano? Would you prefer authorities to evacuate early just to be safe, or wait until there is absolute certainty? Share your perspective in the comments section below, and subscribe if you enjoy exploring these real-world scientific dilemmas with us. As we look at how the situation is playing out right now in mid-2026, Italian authorities are taking concrete steps to prepare for any potential outcome. The Italian Civil Protection Department updated its national emergency plan for Campi Flegrei, dividing the region into different risk zones based on historical data and modern computer simulations. The area closest to the center of the caldera, where the ground is rising fastest, is designated as the red zone. The red zone includes Pozzuoli and several surrounding districts, encompassing over 500,000 residents. Under the current emergency guidelines, if scientific monitoring indicates that an eruption is imminent, the entire population of the red zone would need to be evacuated within 72 hours. Specialized transportation routes, bus corridors, and evacuation trains have been designated to move people out of the Bay Area towards safer regions across northern and central Italy. Adjacent to the red zone lies the yellow zone, which includes parts of Naples and surrounding municipalities. While the yellow zone is not expected to be hit by direct lava flows or heavy pyroclastic surges, it could experience significant ashfall, falling volcanic rocks, and strong earthquakes. Emergency plans for the yellow zone focus on structural safety inspections, clearing ash off roofs to prevent collapses, and distributing protective face masks to shield citizens from inhaling fine volcanic dust. Local communities inside the caldera are not just waiting passively for orders. In recent months, emergency services have conducted large-scale evacuation drills involving thousands of local residents, emergency responders, and medical personnel. Schools across Pozzuoli regularly practice earthquake safety routines, teaching children how to take cover under sturdy desks whenever tremors shake their classrooms. The threat of Bradyseism has become a defining part of daily life for the families who call this vibrant coast home. Meanwhile, structural engineers are working around the clock to inspect older masonry buildings, historic bridges, and utility lines throughout the Bay Area. Tens of thousands of structures were built long before modern earthquake building codes were established. As the ground shifts and tilts, foundation walls develop hairline fractures that can widen over time. Engineers are retrofitting vulnerable structures with carbon fiber wraps, steel braces, and flexible gas connections to reduce the risk of structural collapse or fires during major earthquake swarms. Scientists are also turning to groundbreaking creative solutions to better understand and possibly reduce the underground pressure. Researchers from Stanford University published an eye-opening study investigating the exact physical mechanisms that cause pressure to build up inside hydrothermal calderas. They discovered that when cold groundwater flows down into hot volcanic rock, it creates a self-sealing mineral cap. As water boils below this cap, pressure rises until the cap breaks, triggering earthquakes and ground uplift. The Stanford research team proposed an intriguing theoretical concept. If scientists could carefully monitor groundwater flow and potentially drill targeted relief wells into the shallow hydrothermal zone, they might be able to release trapped steam and reduce pressure safely. While drilling into an active supervolcano carries obvious engineering challenges and risks, the concept shows how advanced fluid mechanics could potentially transform how humanity manages volcanic hazards in the future. If scientists developed a safe way to drill into a supervolcano to release trapped steam, do you think world leaders should fund the project? Type your guess in the comments below, drop a like on the video to show your support, and subscribe to stay updated on the newest engineering breakthroughs in planetary science. The ongoing activity at Campi Flegrei also sheds light on how volcanoes interact with our planet's atmosphere and global climate system. When massive volcanic eruptions occur, they blast billions of tons of ash, sulfur dioxide, and water vapor high into the stratosphere, the second layer of Earth's atmosphere. Sulfur dioxide gas reacts with water vapor in the air to form tiny liquid droplets called sulfate aerosols. These microscopic aerosols act like a giant floating mirror, reflecting sunlight back out into space before it can warm the Earth's surface. During the giant eruption of Campi Flegrei 39,000 years ago, so much sulfur dioxide was injected into the stratosphere that global temperatures dropped significantly for several years. This volcanic winter caused widespread vegetation die-offs across Europe and Asia, altering food chains and forcing ancient human populations to adapt or migrate. Scientists studying ice cores from Greenland and Antarctica can still find chemical layers from that exact prehistoric explosion trapped deep within ancient ice. While the current unrest at Campi Flegrei is nowhere near the scale of that ancient mega-eruption, monitoring the gases released by fumaroles today gives scientists crucial data about how volcanic gas travels through the environment. By measuring how much carbon dioxide, sulfur, and helium escape into the atmosphere every day, geochemists can calculate the total volume of magma degassing deep underground. This gas accounting helps experts estimate how much energy is stored inside the volcanic system. Understanding these atmospheric connections is vital not just for Italy, but for global climate modeling. Major volcanic events are among the most powerful natural drivers of short-term climate change on Earth. By studying small-scale gas releases and minor eruptions today, atmospheric scientists can refine their climate models to better predict how future volcanic events might influence global weather patterns, agricultural yields, and ocean temperatures. The story of the burning fields is ultimately a reminder that human civilization lives at the mercy of dynamic planetary processes that have been operating for billions of years. The continents we walk on, the atmosphere we breathe, and the fertile soils that grow our food were all shaped by volcanic activity over Earth's long history. Volcanoes are not just destructive hazards, they are the engines that build our planet's crust and recycled essential chemical elements throughout geological time. As we look toward the future, the goal of modern geophysics is not to fight or stop natural processes, but to understand them so deeply that human communities can coexist with them safely. The dedicated team of scientists, engineers, and emergency responders working in southern Italy represents the front line of this mission. Their tireless monitoring efforts ensure that if the sleeping giant beneath Pozzuoli decides to wake up fully, humanity will have the knowledge and time needed to keep millions of people safe. What part of this supervolcano mystery surprised you the most? Did you know that the ground beneath Italian towns could rise by over 5 feet in just 20 years without a full eruption happening? Share your thoughts, theories, and questions in the comments down below. We have covered a lot of ground today, from ancient Roman pillars marked by sea clams to satellite radar maps tracking rising magmatic fluids deep beneath the Mediterranean coast. If you enjoyed this deep dive into real planetary science and want to help us share true grounded stories about our world, please take a quick second to hit that subscribe button right now. Don't forget to turn on all notifications, so you are always the first to know when a major science mystery unfolds. Drop a comment below answering our question about living near active volcanoes, and share this video with a friend or family member who loves fascinating stories about nature. Thank you so much for spending your time with us today. Stay curious, and we will see you in the very next video.